Hey, good morning everyone. I wanted to put together a quick video going over the KoolAid Lab. So without further ado, here we go. If we look at these first four questions, these pre-lab questions, remember, these are the same exact questions that we went over a couple days ago, right? So if you need reference in terms of questions 1 through 4, go back and check your notes for December 7th. They're also posted online, and get some background information about the lab. But of course, what we are doing is outlined in part 2. So it's important to understand that we are not making regular KoolAid. I repeat, we are not making regular KoolAid, but instead we should be following the directions outlined in step number 1. And after that, what we will do is we will create a stock solution of KoolAid. So I've had some questions in terms of what is the molarity of that initial solution. Well, it's outlined again right here in part 2. So our molarity is 5.2 moles per liter. All right, so make sure you are following steps number 1 and reading through number 2 to create your stock solution and tasting it. So I don't have the KoolAid in front of me, but I know from my flavors it is much too strong. It might be just right, it might be too weak for you, but for me it's too strong. So what we're going to do, as again outlined in these instructions, is we are going to use dilution to create a more drinkable KoolAid mix. And again, if you feel like it's just right, then creating these new mixes is more of a practice for you. But in my personal opinion and many others, that 5.2 concentration is much too strong. So if we look at number 3, we are going to use our dilution equation. And what I want to point out is what's happening on both sides, okay? So when we look at the M1V1, this is oftentimes, and for sure in this case, the stock solution. This is what we're starting with. This is what we are going to dilute. And when we look at the second side, this is going to be the diluted stock solution. And what that means is it's going to be the stock solution and the water that you add to it. So let's take a look at what number 3 lays out for us, and let's do some calculations. So the first thing we know is we are going to be starting with a stock solution of KoolAid. Okay, and I'm choosing red KoolAid. You may have had a different color, but when we look at this stock solution, we know that this is 5.2 big M, right? 5.2 molar solution. So that's going to be our M1. Well, the directions also tell us to measure out exactly 10 milliliters of this stock solution. So that's my V1. I have 10 milliliters of my 5.2 molar stock solution. And to it, now I'm going to add 90 milliliters of water. So let's look at, again, a diagram of what that looks like. So in a big container, a beaker, a glass, whatever you're using, we should have 10 milliliters of my really concentrated solution. On top of it, we should have another 90 milliliters of water. So my total volume, just like I said over here, my diluted stock solution is both the stock solution at 10 milliliters and the water at 90. So my V2 over here is a combination of these, and we have 100 milliliters. Now I don't know my M2, and I'm going to solve for it. So I'm actually going to do the math up here because I have a little room on my paper, and plug these numbers into my equation. So I have 5.2. Again, this is my M1. That's my stock solution. I have 10 milliliters of it that I measured it out. So that's my V1. And that's going to be equal to my M2. Well, right now, I don't know what that concentration is. I don't know what that molarity is. That's what I'm asked to solve for. But what I do know is that the 10 milliliters of stock solution and the 90 milliliters of water gives me a total of 100 milliliters. So be careful there not to put 90. 90 is not the new volume. It's what we've added to the stock solution. And now we carry out the math. So 5.2 times 10 is of course 52. 100 times x is, of course, 100x, and now we have to get x by itself. So if I divide both sides by 100, I get a new molarity of, let's see, I should be able to do this math in my head, but just in case, we have a molarity of 0.52 moles per liter. So the new solution that we made is much, much weaker, right? About 10 times weaker. So for me, that's too weak, right? We started with a really dilute, concentrated solution that was too strong, really sugary, and now we have something that probably tastes very watery or watered down, okay? So now the task becomes, we've created a solution, let's make a better one. Let's pick two combinations of stock solution and water and develop something that tastes just right. So what you can do for number 4 is any variations of solutions that you want. So let's again go through this and randomly choose to go somewhere in between there. So let's create a new solution. So in this new solution, we're starting with our stock solution. Our M1 in both of these is going to be 5.2. It's what we want to water down, okay? The V1 is going to change based on how much stock solution we put in. I thought 10 milliliters of stock and 90 milliliters of water was far too weak. So what I'm going to do instead is I'm going to try to do, let's say, 20 milliliters of stock. Again, that's that first solution that you made. And instead of 90 milliliters of water, I'm only going to put 80 milliliters of water. Okay, and so again, how would we calculate that? We would use our M1V1 equals M2V2 dilution formula. So let's plug our numbers in. So again, as I said, our M1 is 5.2. It's always going to be 5.2 if we're starting with that stock solution. Instead of 10 milliliters, this time we used 20 milliliters. Okay? And again, I'm solving for my new concentration. What is the molarity of this new solution that I created? Well, as I said, for my second volume, I have to add both the stock solution and the water. So my 20 milliliters of stock solution and my 80 milliliters of water are going to add up to a total volume of 100. And again, just like I did the math for problem number 3, we'll just plug these numbers into our calculator, and instead of 52, right, we're going to get 104 equals 100x. How do I get x by itself? I divide both sides by 100. And again, to give you an exact amount, I'll plug it into my calculator here. We have 1.04 m. So maybe this tastes better for you, maybe it doesn't. Whether or not it tastes better or not, you're going to do another trial 2, and you are going to pick out a different amount of stock and a different amount of water. So if you need help coming up with trial number 2, you can reach out and we can work through this together, but this would be something that you created on your own. Number 5, at what molarity did your Kool-Aid taste best? I've actually done this, and I've found, for me, it is really close to what the Kool-Aid company creates their Kool-Aid at in terms of solution. So for me, it's right around the same. How did yours compare? Again, that's up to you. Whoops. So for now, our extra practice, although it says extra practice, it is still part of the assignment, okay? So this is for you to get better, for you to have some practice problems, to learn this material a little bit better. So let's look at number 1. So number 1, you decide your first batch of Kool-Aid, and number 1 is too concentrated. You decide to make 60 milliliters of 2.25 molar Kool-Aid at this time. How will you dilute your mixture from problem 1 to make a better mixture? Well, again, remember in problem number 1, what we have is we have a stock solution. Okay, so let's start out with our stock solution. Well, our stock solution is a big giant container, and in it we know that we have 5.2 molar Kool-Aid. So how am I going to create my final Kool-Aid solution that is 60 milliliters and at a 2.25 molar concentration? Well, if we look here, we have 3 out of the 4 variables that we need to solve this problem. So let's plug our numbers in and let's see what we get. Okay, so again, the answer and how we make it are going to be a little bit different. So we are going to have my M1 is 5.2. That's my stock solution. I don't know how much of it I'm going to use. I could use 10 milliliters. I could use 100. We don't know. That's why we're doing the math. That's going to be equal to a final molarity of 2.25 at 60 milliliters. And now we have, again, a single variable equation. So 2.25 times 60 is going to give us 135, and that's going to be equal to 5.2x. So again, how do I get x by itself? I divide both sides by 5.2. And now what's important is, what are we solving for? Well, we're solving for V1. So let's get a number and let's see, what does that tell us? So 135 divided by 5.2 tells us that we have about 26 milliliters of stock solution. So how would I make this? Well, again, I want 60 milliliters. So I'd have 26 milliliters of stock, and the rest of that 60, so 60 minus 26, gives us 34 milliliters of water. So that's how I would make it. I would take 26 milliliters of stock and put it into a container. I would then add 34 milliliters of water, and boom, I have a great tasting 2.25 molar concentration Kool-Aid. Okay? Okay, let's take a look at number 2. So number 2 says you want to make your third batch of Kool-Aid to be 70 milliliters of 0.75 molar Kool-Aid. How would you further dilute your solution from problem number 2? In reality, this is a typo. It should be problem number 3 to make this new Kool-Aid solution. So remember, our first solution was far too weak up here at 0.52. Our second solution was a little bit stronger at 1.04. We want to go somewhere in the middle. That's essentially what this question is asking us. So let's start out with what we know. So what we know is the final product. We know what we're making, and our M2 is going to be 0.75, and we want 70 milliliters of it, right? That's what we're creating. Well, what are we starting with? Well, it said we're starting with our solution that has a concentration of 1.04. So 1.04 is my initial molarity, and now I'm solving for how much stock I need. Remember, this is my stock solution in this instance, and from it we can derive how much water we need to add to it. So let's do our math again. So 70 times 0.7 is going to be 49, all right, and 49 is then going to be equal to 1.04x. Again, I'm going to try to sneak this work right up here so we can see 1.04x is equal to 49. How do I get x by itself? I divide both sides by 1.04, and now let's let the calculator do the work. What we get is we get 47 milliliters of stock, right? We're solving for V1, but we want a total of 70 milliliters. So where is the extra solution coming from? Well, that's water. That's how we dilute it. So how do I get to 70? 70 minus 47, which is, of course, 23 milliliters of water. So how would I make it? I would take 47 milliliters, and to it, I would add 23 milliliters of water. Okay? Number 3, the greater the M, right? The greater the concentration, or excuse me, the greater the number in front of that concentration sign means it is more concentrated. So you would go your largest molarity to your smallest molarity, whatever that looks like for you. Okay. Number four, we are using perhaps a different formula. So let's read through it and see if we do need a new formula. So it says, imagine it is possible to buy an 8 molar bottle of concentrated Kool-Aid at the store. If you wanted to make 100 milliliters of a 2.05 molar Kool-Aid using the concentrate, how much concentrate would you need to dissolve in water? And we don't actually need a different formula, okay? It says right here, essentially, we're diluting it. We're starting with a stock, and we're ending with a watered down version. So we're going to use the same exact formula here. Our M1 that we're starting with is 8. Again, we don't know how much of it we're going to use, but what we do know is that we're going to end up with 2.05 molar solution, and we want 100 milliliters of it. So again, now we do the math. So I'll bring this down here, and we can see 8x is equal to 100 times 2.05. So we get 100 equals, or excuse me, 8x equals 205. We divide both sides by 8. And so to give us our answer, we plug it in the calculator and we get 25.6 milliliters. And again, that's 25.6 milliliters of stock. So how do I get to my final 100? Well, 100 minus 25.6 is going to give us 74.4 milliliters of water. So how would I get it? I would take 25.6 milliliters of my stock solution and to it add 74.4 milliliters of water. Okay? And finally, number 5, I know this one is a different formula because it is not asking about dilution, but instead it's asking about how much solute. And we did a problem like this as the opener, so let's set it up. We have solution number 1, 8m equals x over 0.2. Remember, we have liters on the bottom, so we have to divide by 1,000 if we have milliliters, versus our next solution is 4m, and that's going to equal x over 0.6. So now I do my cross multiples. 8 times 0.2 is equal to x times 1. So x here is equal to 1.6. So I have 1.6 moles in my first solution. Same way to solve this problem. So 4 times 0.6 is 2.4 equals x. So my second solution has more solute. It has 2.4 moles versus 1.6. Okay? So if you guys have any remaining questions, obviously I am here to help you, so please reach out. We could set up a time. Maybe it's something I can answer over email, but hopefully this helps, and have a great day.